uh, I'll compare R1, R2, R3. So I can do this by pair, looking at the possible strategies of the column player. So if I compare now in let's suppose that by column player, which is strategy 1, which between of these two strategy would I choose, R1 or R2? Of course, I would choose R2 because it will give me the highest payoff. If C2, I will also choose R2. If column player will choose C3, then I will still choose 2. So therefore, I can say that R2 strictly dominates R1. So this means that I can just remove this, no? Because I know that if I choose R1, I would not be able to. There is still a strategy which is better for R1 across all strategies that can be taken by the column player. Now, if I'm going to compare R2 and R3, starting from C1, I would choose R3, R2 because I get a high return R2. C2 as well, I will get, but in case of C2, I will get what? 8 to 8. No? So meaning I will choose R3. So in this case, none of these two dominates each other. Correct? Because here I would choose R2, whereas here I would choose R3. And here I would choose R2. So I cannot remove any of this strategy. But I can also look at, if I were the column player, because we assume, the main assumption here is that the players are, what's the main assumption? They are all rational. Always remember that. They are all rational. So there is no reason for me to assume that he wants to lose or to earn less money than I would, or to get the suboptimal. So it will also look at his strategy. So since I don't have this, I don't need to compare this anymore. I only need to compare the remaining strategies, the remaining payoff for R2 and R3. So if I look at C1, and if the column player R will choose R2, I will get 2. If you choose R3, I will get 1. So therefore, I would, if I would look at, if my opponent or the role player will choose R2, I would look at which strategy would help me. Now, if he would choose R2, what would happen? My return will be 2. If I use 2, C1. If I use C2, I will get 3. If I will use C3, I will get, just compare muna pair, C1, C2. So I would choose C2, right? Now, if the other player decides to go for R3, what would I choose, C1 or C2? Of course, I would choose C2. So either of this strategy, C2 will always get me a good, a higher payoff. So therefore, C2 strictly dominates C1. So I can just remove this. Okay. Now I'm left with C2, C3, and R2, R3 for the other player. So let's analyze again, okay? So if player R2 chooses, if player R chooses R2, I will get 3 if I select C2. If I select C3, I will get 7. Next, so that's actually C3 has a higher payoff compared to C2. Now, if I use R3, if the other player will adapt R3, I will get, for C2, I will get 2, and for C3, I will get 3. So therefore, what would I do? C3, in fact, dominates C2 in this case, right? So I would cancel this. Because C3 always dominates C2. Now, I am already C3. So meaning, column player C will select C3. But what if I'm the column player R, or the row player? So if I'm going to compare R2 and R1, if my opponent will select C3 as a strategy, of course, I would select R2 because I will get a payoff of 2 compared to 1. So therefore, I can cancel this. So if I were the player R, I would choose R2. And if I were the player C, I would choose C3. So that's the idea of iterative dominance. So we can remove strictly weakly dominant strategy. And if the strategy is strong, strictly dominated, it will actually result to independent path. Right? So it doesn't matter. I will always get to the same strategy. Okay? But if they are only weakly, weak dominance, then it is actually path dependent. I may get to a different strategy depending on whether I compare first R1, R2, or I compare first R1 and R2. So that's just the idea. Okay. Okay. So this will just illustrate actually the point, no? So if I start to compare itong, let us say, R2 and R3, I would choose R3, R2, because it's dominated. And then if I compare now, C1 and C2, of course, so if you compare 0, 1, so C1 is better. But if player 2 will adapt R2, I can see that it's both 0. So meaning, since meron tayong payoff na equal, weakly lang siya dominated, no? Meron din namang so I can say, kasi weakly dominated itong C2 by C1, then I can eliminate that. Okay, so I end up with 0, 1, and 1, 0. So if I were column player C, I would choose C. C1. So if I choose C1, what would the column player R will choose? Of course, he will choose what? He will choose R1 or R2. He will choose R1, okay? Because it's dominated. So therefore, the strategy here is that for column for row player, he will choose R2, and for column player, he will choose column 1. But if first compare R1 and R2. Kanina, di ba, I first compare R2 and R3. Now, if I compare first R1 and R2, then I can remove the R1 because it's dominated by R2. Then I can remove C1 because it's dominated by C2. And if I compare R2 and R3, then I would remove R3. So what happened now? Since weak lang yung kanina, iba yung na-obtain ko na strategy. So yan yung sinasabi nating path dependent, no? Kasi para siyang path, first compare R2, R3, then compare C1, C2. Then ito namang isa, first compare R1, R1, R2, di ba? Then compare C1, C2. So magkaibang path ng comparison, magkaiba yung binibigay niya na strategy. Okay? So, iterated strict dominance is path independent. So, kung dominant talaga ang action, meaning walang mag-equal na payoff, then it's path independent. So, whichever path you take first, you will end up with the unique strategies for both players. Okay? So, that's it. Any question? Okay, Nan, thank you. Let's proceed. So, can a given strategy be iterated? So we have already done. Is there some part of elevate? Only one strategy per player remains. So these are just some of the questions. So the question is more on the complexity, no? And then for weak dominance naman, NP hard siya. With or without dominance by mixed strategy. Okay? So, but of course, there are some games in which no strategies are dominated by the others. So R1, tignan nyo si R1, compare nyo kay R2. Meron bang instance na ma-dominate ni R1 si R2? So tignan natin first ito kung C1, R2. Diba? Sa C2 naman, R2 pa rin. Pero pagdating sa C3, R1. So wala tayong ma-remove. Kung si R1 naman si R3, ano naman ang kanyang, mayroon kayang strategy na ma-dominate niya? Kung R1, R3, kung C1 si column player, then we choose R3. Kung C2 naman, then we choose wala. Wala, 2-2. Ito naman, tie. So therefore, ano pwede natin magawa dito? Dominated, di ba? Weakly dominated ni R3C, R4, si R1. So what happens? Pwede natin siya i-remove kasi weakly dominated lang naman siya. Okay? Okay. Now, compare it with R2 and R1. 4-3, 2-3. So hindi natin pwede ma-remove kasi for C1, mataas si R3, pero for C2, mataas naman si R2. So therefore, we cannot really say na dominated ni R2 si R3 and vice versa. Okay? So let us look now C1, C2. So C1, C2, kung R2 naman, kung R1, sino ang better? Si C1 or si C2? Pareha lang sila, diba? And then 2-0. So therefore, weakly dominated si C1 ni C2 because si R, tsaka si R dito is, ang payoff dito is 3, payoff naman dito is 3. So kung equal lang sila, Pero kung R3 naman i-apply, maging advantageous si C1. So kasi weakly naman siya, pwede natin i-remove si C2. Okay? Diba? Ma-remove. Na, compare natin si C1, C3. Kung mag-R2 siya, dominate, mas better si C1. Kung si row player mag-R2, better si C1. Kung si row player mag-R3, better po si C3. So wala yung mag-dominate. Balikan natin si R2 tsaka R3 kasi nag-eliminate tayo dito ng C2. Kung si R2 naman, kung mag-C1, better si R2. Pero kung mag-C3 naman, better si R3. So, we end up with this, no? We end up with this payoff. Kumbaga, we can reduce it into C1. We can reduce to C1. Tapos C3. Tapos R1. Wala di R1. R2. 3, 4, 2. At saka 0, 1, 1, 2. Walang strategy dyan. Other player that dominates, no? That dominates the other strategy. So yan yung sinasabi niya, there are some games or there are games which no strategies are dominated by the others. Okay, so we cannot use here the iterated dominance. Gets ba? I hope gets, no, sa mga tao. Sige dami, give me a thumbs up kung na-gets. Good. So, balikan natin ngayon ang zero sum. Okay, ano nga yung zero sum game? Let's have Kisha. Ano nga yung zero sum game, Kisha? Kisha, saan na si Kisha? Ano nga yan, Kiss? Ano nga yung zero sum? Zero sum? Okay, nag-raise ng hand na lang si Vincent. Si JD. Sige, JD.
Sir, ang zero sum sir is if mag-add yung dalawang ano ng players is zero siya.
Okay, pero ano ibig sabihin yan?
Sir,
Practical.
kung anong gain mo yun din gain ng kalaban mo, sir.
Kung ano yung?
Hello, hello?
Hello, ano yung? Ano? Ano yung?
Hello?
Oh,
Sir, sir.
oh. Ano yung pag-interpret pag zero sum? In terms of payoff for each player?
Ang player, sir, is same sila ng gain and loss, sir.
Okay.
Negative lang value.
So what you will gain your player will lose the same amount. Diba? So, same way, kung ano yung malose mo, yun naman ang maging gain ng kabila. So, meaning, we can actually simplify the matrix. Rather than writing it like this, can actually write this like 0. Can just write it as 0. Okay. Kung siya isulat as 0 lang, negative 1, 1, 1, 0, negative 1, negative 1, 1, 0. Pwede ganyan lang matrix with reference to the winnings of row. Why? Because we would know, no? Na kung 0 yung gain mo as the row player, 0 din ang loss ng kabila. Kung negative 1 yung payoff mo, meaning you lose 1 unit, siyempre it will be gain to the other player. So, para redundant siya kung isulat pa natin this way. So, we can just do this. So, ang goal ngayon actually for row player is to maximize. And the goal of the column is to minimize this value. Okay? Kasi kung i-minimize niya yan, meaning maximize ang kanyang payoff. Gets ba? Okay, may I raise your may I see your hands, likes kung gets ba? Okay. Okay, good. A general sum K-player game can be more than a zero-sum K plus 1 player game by adding a dummy player, absorbing the remaining utility. So 0 games with 3 or more players have to deal with difficulties with some games. This is why we focus on 2-player zero-sum games. Okay? So ito yung example no kung if you are going to multiplayer game no, so ano yung ma-earn mo, yun yung ma-loss nung iba. Okay? Okay? So, we focus on 2-player muna because that would be, well, madali lang siyang i-extend for K plus 1 player. Okay? So, we have here our definition. A pair of strategies is in equilibrium if and only if it holds that once this pair of strategies is chosen, none of the players could reach better outcome by unilaterally switching to another strategy. So yung ginagawa natin kanina, we are actually finding the equilibrium. Okay? So mayroon tayong technique ngayon na ginagamit na based actually siya sa iterated dominance. Pero meron siyang madaling, mas siguro efficient way to look at it. Kung ang game natin is zero-sum, we call that the minimax condition. So ano ba ibig sabihin? Strategies that fulfill the minimax conditions are equilibrium and only a sufficient condition, meaning that it's insufficient. So meaning, pag ma-achieve mo ang minimax, then that's equilibrium. Di ba? Yan ang ibig sabihin na sufficient. Pag hindi naman siya ma-achieve, meaning, di ibig sabihin, wala equilibrium. Di ba? Yun ang ibig sabihin ng sufficient. Pero sinabi natin net, kung necessary siya, before siya ma-equilibrium, dapat minimax. Kung necessary. But since only is sufficient, the minimax is automatically that implies the equilibrium. Pero kung hindi naman siya minimax, it doesn't mean walang equilibrium naman. It's just that baka meron tayong mahanap, but hindi siya minimax. Okay? So how? Yan ang question. How? Ricarabaw. Di ba? Debatutin. Ano ibig sabihin? Find the minimal value of the row and the maximal value of the column. So yan yung clue. Or yan yung actually, well, it's not actually, it's actually the way to find the minimax. So balikan natin ito, problem na ito. Okay. So ano yung sabi niya? Minimax, find the minimal value of the row and the maximal value of the column. Okay. So hanapin muna natin sa minimax ang mga minimum ni row. So ano ang minimum ni R? Ano ang minimum? Remember this is zero sum . So the idea with zero sum is that we can just use this rather than writing the 3, -3, -3, 3. You can just use this way of matrix. So ano yung ginagawa ni minimax? Sabi niya, hanapin mo daw yung minimum ng bawat row. So hanapin mo natin ang minimum ni R1. Ano dito ang minimum niya? R3. Ano naman ang minimum ni R2? Sabi niya, ang minimum daw dyan ay R, itong value. Hanapin ang minimum ni R3. Ano ang minimum? 31. Now, hanapin mo ang maximum ni maximum sa bawat column. Si C1, ano ang maximum niya? 4. Si C2, ano ang maximum niya? 7. Si C3, 7. So ano yung magiging equilibrium? Yung equilibrium, yun yung payoff na minimum siya sa kanyang row at maximum siya sa kanyang column. So ano ang maximum at saka minimum? It's actually 4. So ano yung mga strategy na nag-correspond sa kanya? C1 and R2. Meaning, the equilibrium strategy is R2 and C1. Ganyan lang ibig sabihin ng minimax. Okay? Gets ba? I hope gets, no? May I get okay? Sige, kung na-gets, Jod, you will solve this. Solve nyo muna ito. Wala, paano alisin itong ano? Sige, sino ang mag-volunteer na mag-solve nitong first? Ito muna. R1, R2, R3, and C1, C2, C3. Sino mag-volunteer? Just raise your hands. Just raise your hands. Can somebody? Okay, si Bala. Okay, si Bala, try to solve this. Find the minimax or the equilibrium using the minimax.
Mag-drawing ko, sir.
Siyempre.
Sige. So, okay. So, ang minimum sa R1 kay
Maka-annotate
7.
ka?
Yes po, sir. Makita.
Okay.
Ang minimum sa R2 is -5. Minimum sa R3 kay -2. And then, looking at the columns, ang maximum sa C1 kay 9. Maximum sa C2 kay 8. And then, maximum sa C3 kay 7. So, atong equilibrium point is R1, C3, which is 7.
Okay, good. Lahal, ano niyo eh? Sige, let's have another one. Si Baho. Nag-raise mo siya ganiya. Ato na lang ihatag sa yahan ni problem. Kaya kini ba is solve ni pagitaad dira ang minimax.
Sige, sir. Wait lang, sir. Kaya ko last slide drawing. Dala, okay.
Okay.
Ang minimum sa column ay sa R1 kay ang 1 na pangit. Kita certic kay pangit. Ang minimum sa row 1 kay ang R1 ay ang sa C2, then sa R2 ang minimum niya kay ang 1 na napod sa C2. Sa R3 ang minimum kay yani siya. Then ang maximum per column sa C1 kay 5. Then ang sa C2 kay pareha sila ang kaning 1. Then ang sa C3 kay 9. So ang atong equilibrium point kay duha. Ang kaning 1 sa R1 C2 o R2 C2.
Okay, good. So, ano ba ibig sabihin ng equilibrium? When we say an equilibrium, it means that kung kana nga strategy ang pilion, meaning kung mag-switch ang isa, ang problema is dili siya maka-gain. Okay? Because kung mag-unitary switch lang siya, possible na mag-lose siya. Okay? So that's actually the big sabihin. So none of the players could reach a better outcome by switching to another strategy. So for example, kung R2C to equilibrium, ikaw nag-decide kag R3, pildi ka. Kung ang isa ka player po nag-decide R1, pildi ka. Ha? Now, kung nag-stick si R2 o nag-stick si row 1 o R2, niya ikaw si C1 nagbaliktad nagpili kag C2, pildi ka mas dako -5. Kung nag C3 po ka, -6. So kung unitary switching ka, you will not get a better outcome. Mo na ibig sabihin ng equilibrium. This is of course assuming na bright ang tao. Kaya kung bulok ang si R1, C2 could always select C2 because it will give him the highest payoff. Diba? Kung bulok si R1, bulok pa siguro na si R1, so mag-C2 ko. Niya mo pili pa dyan si R1 o si R o R1 pa. Pili siya. Okay? So, mawala na ginamin sa equilibrium. No? Now, kato nga mga strategy nga akong dimension, mo ito ginatawag og pure strategy. Meaning, isa lang ka strategy ang imong gamiton all throughout. No? Because na equilibrium, because if you change, then it will not lead to a better outcome. But as we have already shown na apoy mga problem na wala yun siya ingon nga best strategy na pure, no? Best pure strategy. Wala ingon ana. So better na instead of adopting a pure strategy R1, R2, R3 or C1, C2, C3 for column player C, why not adapt tayo ng ginatawag natin na mix strategy. So, pag sinabing mix, wala kayong strategy nga. Katulad yun imong gamiton. Pwede mo i-mix. So, let us say, R1 ka 50% of the time, R2 ka 50% of the time. So, example niyan is yung rock, paper, scissors. No? So, you can come up with a strategy na 50% of the time mag-rock ka, 50% of the time mag-scissor ka. Dili ka naga-paper. Or pwede po na 40% of the time rock ka, 40% of the time scissor ka, and 20% paper ka. Di ba? Nga po yung mga anang strategy. So, in response to that, you know your opponent will play 50% of the time scissors, 50% of the time rock. What is your strategy? Kung ikaw. Yeah. What happens to this? It actually become a risk. No problem. So, kung ikaw mag-rock, di ba? Di ba? So, the rock gives you di ba? The rock gives, siyempre, kaya na may probability, you would assume na the expected payoff would be just the expected, di ba? 0.5 times 0 plus 0.5 is 1. Paper naman gives 0 and scissor gives negative 0.5. So the best response to your opponent's strategy is to always play rock. Because if you play rock, meron ka pa ring expected na 0.5. Okay, good. So, simple naman. Pag naging probability, always go for the expected. Kasi if not, then mahirapan utility ang gamitin. Okay? Okay? Good. So there is always some pure strategy that is a best response. So suppose you have a mixed strategy that is a best response, then every one of the pure strategies that the mixed strategy places positive probability on must also be a best response. Okay, so sa may meeting ani. So this is actually response strategy. Okay. So a response strategy is, you know that your other player is playing a mixed strategy. Then you can also have a pure strategy that you can respond to this. Pag sinabing pure, isang strategy lang. Okay? Okay, good. So let's play the game of matching pennies. Sa pa pag-pronounce para dili kay bastos paminaw. Pennies. Penis. Pennies. Okay? So let's try to analyze this matching game. So tingnan muna natin, meron ba siyang analyze muna natin, is this a zero-sum game? Yes, because if you sum this, you'll get 0. Now, let's look at kung meron ba siyang equilibrium. Okay? So, kung titingnan natin si L, comparing it with R, mapansin natin, if L will adapt a strategy, kung si Dem will adapt L, better si L. Pero kung R naman, better si R. So therefore, hindi siya dominated. On the other hand, dito naman tayo kay Dem, kung mag-adapt si As ng L, ano ang better? L or R? Si R. Pero kung mag-adapt naman si As ng R, better si L. So wala tayong equilibrium. Kung wala tayong dominated strategy. So most likely, we will have a mixed strategy. Tama? So dapat mix ang strategy natin rather than pure. So we assume that the opponent knows our mixed strategy. So alam niya yan na since walang equilibrium, magmi-mix yan siya. Diba? Okay? So, ano ang ating magandang mix strategy? Yan ang ibig sabihin. So, if we play 60-40, no? Ano yung magiging payoff? So, suppose si opponent will play R. So, ano yung strategy natin? 60-40, di ba? So, our payoff there will be 60.6 times -1. Ito yung payoff. And 0.4 times 1. So, the result would be -0.2. Now, what if naman player will play L? Ano lalabas? 0.61 and 0.6 times 1 times plus 0.4 times -1. So, -0.4 plus 0.6. Ano magiging result? That would be plus 2.0. Correct? So, kung mag 60-40 siya, of course, our opponent will play R because magiging mataas yung kanyang payoff compared sa mag-play siya ng L. So the question is, what's optimal for us? Ang ibig sabihin nito, how do we set this percentage? Para whatever yung i-apply ni L, i-apply ni Dem, malaki yung ating magiging or optimal yung mix strategy natin. And we can say na correct? So, paano natin gagawin? So, ito naman, kaiba naman ito with sensitive target. Let us say 50-50 ang gagawin. Then, kung 50-50 naman, 0.5 times 1, 0.5 times -2. Di ba? What if we play 55-45? Ano mangyari? So, pwede siya mag-L, pwede 35, pwede din siya mag-R, maging 0.1. In either case, he loses. Tama? Ang opponent natin. So, ito medyo sensitive siya na target because pinalakihan natin yung R. Kung R tayo, L yung isa, pinalakihan natin. Yung left yung isa, tapos right tayo. Pinalakihan natin. Okay? So, we found, no? 0.55 tsaka 0.45. It will give us meron talaga tayong at least 0.1 na gain. Okay? So, we get 0.35 greater than negative 0.5. So, if we choose a different percent, no? Kung 50-50 lang, negative. Pero kung 55-45, then negative. So, yun na nga ang tanong. Di ba? Yun na nga ang tanong natin. So, what is the optimal strategy? So, suppose, no, palakihin pa natin kaunti. Gawin natin 60-40. So, gawin natin 60-40, ang mangyari ay Chone can choose either L, so 0.6 negative 1 plus 0.4 times 2. So, you get 0.8 minus 6, so 0.2. Then R gives them 0.6 plus negative 0.4. So again, this is positive. So we get what? Negative 2. Because for the opponent, they will get what? They will get negative 2 either way. So that is actually gain for us. Tama? Ito naman this is actually computing, no, the payoff for the opponent. Actually, opponent pala yun kanina. Opponent. So, mali pa sinabi ko. Now we get 0.1. Actually, we lose. We lose 0.1. At least negative 1. Because this is actually the payoff for the opponent. Okay? Dito naman, negative 2 yung makuha natin. Ha? And this is actually the maximin strategy. Bakit? Because negative 2 and 0.2 yung ating makuha na result. So, kumbaga yan yung minimum na maka-maximum. Kagaya ng maximin natin, di ba? So, sa possible worst, yan yung pinaka-maximum. Kasi kung dito tayo magtatingin, ano yung worst natin dito? Negative 35. Tama? Pero, ang minimum is 0.1. At in this case, minimum natin dito is 0.2. Negative 0.2. But, sure tayo na maging negative 0.2. Unlike dito, na meron tayong possibility na makakuha ng negative 35. Okay? So in this case, this is the maximin strategy. Whatever the opponent chooses, we get the same, negative 2. So this is the maximin strategy. Kumbaga sa lahat ng mga minimum, yan na yung pinaka-maximum. Gets ba? So wala naka-gets. Pakitaas na ang atong mga kamot. Kung wala naka-gets. Okay, naka-gets na. Okay, so meaning atong minimum dere 0.2. Ang atong minimum dere sa PCAS 0.1. Tama? So, pilion na nato tong strategy. Di ba? Strategy na maka-maximize sa ato minimum nga utility. So, ang minimum is 0.2, negative 0.2, negative 0.1, negative 0.2, di ba? Then, we have the maximum, which is negative, comparing negative 0.2 and negative 0.35. So, the maximum there is negative 0.2. Okay? So, kumbaga, para mas klaro, what is the minimum for this? For us, ha? Because this is opponent. So, we lose negative 35. This is the minimum. And if we choose 60-40, so may minimum dire. Negative 0.2. So sa duha, asa may mas dako? Negative 0.2 or negative 0.35? Siyempre, mas dako ang negative 0.2. So therefore, that is actually the maximum strategy. But the question is, how about himo na tog 70-30, di ba? 90-10, 95-5% sa man ato ang makuha na nga ano. You can actually perform the characterization. Okay? But later, we will try to solve that in a way na makabalo na ta kung unsa ang ilahang. Unsa ang pinaka-best na percentage kung mag-mix strategy ta. Okay? So, kung baliktaron po nato, we suppose we know their strategy. So, we compute now the payoff natin ay compute. Tama? So, to do that, we just have to do the minimax strategy. It's very similar to the equilibrium when it's 2 zero-sum, di ba? We have to find the a minimum per row and the maximum. So therefore, in this case din naman, since we are trying to maximize, no, to maximize our strategy, first we need to find the maximum and then find the thing that minimize across the maximum. Because, of course, if we always choose the maximax, they can always find a strategy no na mas dako ang ilahang makuha. So we are just being, kumbaga, pessimistic here, no? Because we are looking for the minimax strategy. Okay? So according to minimax theorem ni von Neumann, katong upaw na mathematician, maximum value is equal to minimax value. And this is actually called the LP duality. So, unsa may implication sa theorem? Implication sa theorem, symmetric siya. Meaning, pwede nga, ang reference nato kita. We solve for the minimax on our case. And the result would still be the same if we consider them as the reference. So they know our strategy and we compute for the maximum. Okay? Gets ba? O medyo libo gamay. So, pwede na to tanawon lang ang isa ka part kung zero-sum, no? Tanaw to isa ka part lang. Kita, ato tanawon lang ang ato ang payoff. And assuming We know their strategy. Pwede po, tanaw na to sa ilahang part. Sila ang, burag sila ato ang, we put ourselves on their shoes, no? We wear their shoes. So, ila pong buhato na mag-maximin sila. Whichever the two we adapt to compute for this probability, we will get the same set of probabilities or mixed strategy. Gets? Okay, so ano lang na, basta mo ng theorem. Let's solve this. And then solve this. These are all mga zero-sum na game. And of course, if we look at this, no, wala siya equilibrium na pure. No, to 0, 0, 10, wala. Lamang gyapon si 20, lamang si 10. Kung kita po si C, if we look at that, lamang si C2. And then here lamang si C3. Now, our question is, ano ang magandang mix strategy? Di ba? Usually, manjo na yung mga question. Same thing here. No? How do we know the best strategy? Okay, so but before we continue siguro, let's have a short break para dili po ta ma-zoom burnout. Let's have 5 minutes, no? We go, okay, 6 minutes. We'll resume at 3:40. Okay, thank you.